Alrighty. So if you've been doing this for a while, right? It's been almost what, like 2 weeks. This shouldn't be that hard. So this one, it says identify the similar triangles. Let's look at the first one, A. Are these two triangles similar? ABC and KLM.
Yes.
Okay, how do you know?
They have similar angles.
Actually, they have the exact same angles, right? So this angle and this angle is the same. It looks like they also have a 90-degree angle there. And automatically, if two angles are the same, the third one's also going to be the same. What's the scale factor here? Is there a way to find it? So that's a trick question. You can't find the scale factor. Cool. If you want to find the scale factor, you need at least one side of both the triangles, and we don't have the side lengths of anyone, so they're not. What about B? Are these two triangles similar?
Yes.
Yes, which angles are the same? J and G, right? These two that are J are, yeah, and then N and P, and then T and R. So yeah, they are indeed similar. What about C? Are there two triangles for question C? So there's a smaller one, this one, UVW, right? And there's the bigger one, VTX. Are they similar?
Yes.
Okay, which angles are the same in both triangles?
V and then W and X.
Yeah, so both of these triangles have this, and because these two lines are parallel, this angle will be equal to this, and this angle will be equal to this. So therefore they are indeed similar. Okay, D, we have two triangles. Are they similar?
Yes.
Okay, which angles are the same?
C.
Okay, that's an easy one, right? Because opposite angles are going to be the same. Is there any other one? That one's a tricky one. B and E or B and D?
B and D.
Yeah, this angle is going to be the same as this. Now, why is that the case? Because it's like a parallelogram. If you just kind of build it, right? We have some things going on here, but this angle is this, and the B angle is up here. They're going to be the same, right? Whereas this angle and this angle down here in a parallelogram adds up to what? Called supplementary angles. If this is 20, what is this?
$160.
Yeah, so they're going to add up to 180. So that's it for this question. It's a pretty basic one. We don't care about that. Let's look at question 3. So they've already told us that all the triangles here are similar. Okay, even if they didn't tell us this, for A, we know D is A, B is E, and then the C is F. What's the scale factor? Now these ones are going to be really quick. 4, 6, 7. Compare this and this. Now that we know they're similar, what's the scale factor?
2.
Yeah, so that means what's F gonna be? If this is 4, what's this side length?
8.
8, right? What about D?
14.
14. This one's also easy. We know they're similar. The scale factor is 3. That means this is gonna be 30. What's S gonna be? We know this is 18. We know the scale factor is a 3. Yeah?
It's 6.
6. Yeah. Now this one is gonna be a little bit trickier. What do you think the scale factor is? We know they're similar.
0.5.
0.5. So this one's a little bit tricky. You see this side length, WX,
Mm-hmm.
is going to be K, the scale factor, times the side length BC. This one, the base, and this one, the base are related. So this is 4. K is, we don't know that yet. BC is 6, right?
Mm-hmm.
So I guess I should have done it the other way around. K is gonna be 1.5. It was the other way around. It's always gonna be K times the smaller guy is the bigger guy. So K is 1.5 by doing 6/4 for these two. Now the question is 5 related to the 9 centimeters, or is 5 related to this B unknown? Which sides are similar?
B.
Yeah, exactly. It wouldn't make sense if it's 9 because we know the scale factor is 1.5. Then this should have been a 7.5. No, this is gonna be B. 5 is related with this. One way to see this is just look at the angles that 5 is touching. 5 is touching this angle up there that has like one line, not the double bolded one. And it's also touching the angle with a point, right?
Mm-hmm.
So it cannot be 9 because 9 is touching the bolded one. So it must be BAC. So what's gonna be W now that we know the scale factor is 1.5?
It's 6.
Yeah. And that's it for this question. So it gets a little bit tricky when they flip the triangles. But if you really want, what you can do is you can redraw it, right? Like this one, if you just flip it upside down like this, we know the base is 4. This thing is up here, right?
Mm-hmm.
This thing is gonna be here, X. This thing is gonna be here, W, Y. And we know YW is 5. We know XY is W. So there you go. And this one looks very similar to this. So yeah, they can change the orientation basically, which makes things a little bit more tricky, but it's the same thing. It says no calculator here, so find the length of X. So for the first one, X is down here. What do you think it is? Well, first we know that these two triangles are similar because opposite angles, right? And using the parallelogram law, because this side and this side are parallel, this angle must be this angle here. So they have two angles that are same. That means these two are similar triangles. Yeah.
Is 8.
Yeah, X is 8. It's just easy like that. Let's go to this one. How do you find the scale factor for B?
Is it 2.5?
Yeah, it is. So K is 2.5. We're trying to find X. X is down here. basically we need to turn this into an equation in order to solve this. We know K times the smaller side, which would be AD, right?
Mm-hmm.
This is equals to the bigger side, AB. We know the scale factor is 2.5. We know AD is 6. What's AB? It'll be in terms of X.
15.
No. Well, we're trying to find X, right? It would be
Mm-hmm.
15, but we're trying to find what X is. So AB, right? AB in terms of X would be 6 plus X. In other words, AB is AD plus DB, right?
Mm-hmm.
Because we're trying to find what X is. Yeah, AB would be 15. All right, we can't use a calculator. What's 6 times 2.5? I think you already said this, 15, yeah. So X is gonna be 9, and you're done. Easy peasy. So the trick, this angle is equals to this angle. And when you're writing the big side in terms of X, it's gonna be X plus 6. All right, this one. Using the dimensions of the surveyor's triangle, find the width of the river. So this is the width of the river up there. Are these two triangles similar?
Yes.
Yeah, they are, because they both have a right angle here and here, and they have opposite angles here, which are gonna be the same. How do you find a scale factor?
50 over 17.
So K is gonna be 50 over 17. That means this guy, 15 times 50 over 17, is going to be X, right? Smaller guy
Mm-hmm.
times the scale factor, bigger guy. It says nearest meter. I'm gonna cheat here. By cheat, I mean I know 51 over 17 is a 3. So the scale factor is approximately 3. So X is gonna be 45. Because it says nearest meter, and that's probably what it is. If we want to check 15 times 50 divided by 17, actually that's not right, because 50 divided by 17 is 44.11. So the answer should be 44. But here it says, it doesn't say you can't use a calculator, so the answer is not. This is just an approximate answer. This, they will ask you if they say not, you can't use a calculator, but here you can. So the answer is actually 44, not 45.
Mm-hmm.
Find the length and width of the pond. First of all, what shape is this?
It looks like an oval.
Yeah, it is. There's a name for it. It's not a circle. It's called an ellipse. There's some formulas there as well, which you'll get into. Maybe we'll get into it someday. It's like a circle, but it's not really a circle. And the formulas are going to be a little bit different. A circle is way easier to deal with because it's symmetrical
Mm-hmm.
everywhere. But this one, it's not, it's symmetrical if you chop it in half. But if you compare like this, you get this is equals to this. But if you cut it like this, you get this is equals to this. And this bit is not equals to like this bit. So things get a little bit more complicated. Anyways, what are we trying to find? We know AB is 14. We know BC is 11. So the trick is to find XY. Interesting. Width of the pond is would be XY. So this is X. All right, are these two triangles similar?
Yes.
Yes, they are. They both have a 90. They both have the same angle. X is going to be equals to B. So how do we do this question?
Um.
You need a keen eye for this. I'll give you a hint. You need to look at the diagram. Look at this part of the diagram. You'll see that some things, they've given us something that we can work with. Notice how AC and CY are the same, right? So can we find AC?
Use Pythagoras theorem.
Yeah, we can use Pythagoras theorem to find AC. AC will be the square root of 14 squared minus 11 squared. That is some numbers, 8.66. So AC is 8.66. That means CY is also 8.66 because they're equal. You see this line? That means these two side lengths are equal. That means AY would be just this times 2. It'll be 17.32. Now we can find the scale factor here. We know AC times K is going to be AY, right? The smaller side length times K would be the bigger side length. So K, well, this one's easy. It's just going to be 2 because we added them up. So K is going to be 2. Okay, if the scale factor is 2, what's the side length XY?
It's 22.
Yeah, and that's it, and you're done. All right, to measure the height of the tree, we have some things going on. Cynthia's brother, so this guy here, BR, is 1.2 meters. And this guy is 4.2 meters from Cynthia. So which side length is 4.2?
R and C.
Yeah, RC is 4.2. What is 6.5? It says from the base of the tree. Yeah, I don't know about the grammar here, but which side is 6.5?
E to C.
Yeah, I don't know, right? I don't know. Like this is a little bit tricky because there's like some mistake here, grammar mistake. Anyways, the way I'm looking at this, Cynthia's brother is the subject, right? This guy is the subject, who is 1.2 meters tall, is 4.2 meters from Cynthia, who's standing at C. Should be a comma here, maybe. And 6.5 meters from the base of the tree. I think this one is talking about the subject. I think it's going to be ER. This side is 6.5. Find the height of the tree. Alrighty. Are these two triangles similar?
Yes.
Right. They both have a 90 degree here and here, and they both share C, right? Side length C. Alrighty. So what do we do next? We're going to find the scale factor. How do you find the scale factor?
First year out of 6.5 and 4.2.
All right, so EC is gonna be 6.5 plus 4.2. That'll be 10.7.
Divided by 4.2.
That's not gonna be a nice number, is it? 10.7 divided by 4.2. That's like 2.55. Alrighty, so that's the scale factor. K is 2.55. What next?
You multiply that by 1.2.
Yeah, so 2.55 times 1.2. Therefore, the tree is not that tall. It's 3.05 meters. And you are done. I don't know why now there's some random things here. So we have like a linear equation here. It says solve for A. What do we do here? So this is just algebra.
You multiply by 6.
Multiply what by 6?
1.
So you mean multiply both sides by 6?
Mm-hmm.
So you're trying to subtract fractions, right? Find the LCD. So the LCD is 30, right?
Mm-hmm.
So you would need to multiply this by 6. You'll need to multiply this by 5 equals 1, like that.
Mm-hmm.
Okay. So you get 6a minus 5a over 30 equals 1. What's 6a minus 5a?
It's a
It's a. So a over 30 is 1. So what is a?
30.
30. And it says check by substituting. So that means is you just plug 30 as a and see if you get a 1. So if you want to check, you just put 30 as a in there. So 30 over 5 minus 30 over 6. This is 6, that is 5, that is 1. That's what you have on the right side. So you're good. Pretty straightforward, just adding and subtracting fractions. All right, we have a cubic function here, but it doesn't really make a difference. Is there anything we can pull out? I think 4 goes into all of them.
Mm-hmm.
So I can pull out a 4. Anything else?
4x.
4x is good, right? So what are you left with if you pull out a 4x?
6x squared.
Yeah, 6x squared, and 116 divided by 4 is 29, minus 29x, plus 140 divided by 4 is 35. 35, like that.
Mm-hmm.
Now this is gonna be tricky. Can we factor this further? Because you can't really pull anything out right now because 29 is a prime number. Basically the question is, can you man this, right? We're looking for two numbers that multiply to 35 times 6. So 210, yeah?
Mm-hmm.
The fact that they multiply to a positive number means our two numbers are going to be either both positive positive or they're going to be negative negative, okay?
Mm-hmm.
But if you see what they add up to is negative 29, that means our two numbers have to be negative negative. Cool?
Mm-hmm.
So now it's just a matter of guess and check. Look at this. I'm gonna guess and check. Negative 20 times negative 9 is 180. That's not good enough. Negative 19 times negative 10 again, we know these two should add up to 29 every single time. This is 190, right? The next one would be 18 times 11, which is what? 198. We're getting there. Now, if the next one doesn't work, then that's it. The next one will be 17 and 12, right? Negative 17 and negative 12. I don't think that's gonna work. 204, actually, we're not done yet. The next one will be 16 and 13. That's 208. The last one is gonna be 15 and 14. You see that? So 15 times 14, it does work. So there you go. That's how you can guess and check for bigger numbers. You saw what happened here? So you don't, even if you don't know that, who's going to remember that, but it does work. You can actually kind of eliminate having to check some of these. Like for example, this will never add, when you multiply them, you're never going to get a 0 there. So you can ignore this, you can ignore this, you can ignore this. So you check for this too, and then maybe just jump here as well. So there you go. It's going to be negative 15 and negative 14. Didn't look like there was going to be any, but turns out there is. Negative 15 and negative 14 are your numbers. So 4x, 6x squared minus 14x minus 15x plus 35. What can we pull out from the first two? Is there anything that we can pull out?
2x.
Yeah, 2x. What are we left with if you pull out a 2x?
3x minus 7.
Right. The next one you can pull out a 5. Also going to be left with 3x minus 7. So it's going to be 2x minus 5 and 3x minus 7, like that. And that's going to be the final answer. Make sense? So this one was a little bit more difficult because of the numbers were pretty big and weird. We don't know what's happening here. 4 minus 7 is 3. Well, it's negative 3, but negative 3 squared is positive 9. Minus, this will be 4, right? 4 squared is 16. So the answer is negative 7. I don't know why this is here. All right. We have a system of linear equations, which means we have multiple equations. There's 2 equations that they've given us, and there are 2 unknowns. How do you solve a system of linear equations? Any ideas? Do you remember doing this? You can either do, I'm going to show you both ways. There's 2 ways to solve this problem. You can use substitution. Okay, that's the one way. And then another way is you can use elimination. One of them is better sometimes, the other one is better some other times. This one, elimination is easy. But anyways, we're going to look at substitution first. So your first equation is x plus y equals 6, right? You're going to rewrite this either in terms of x or y. It doesn't matter. So x will be 6 minus y. Yeah? Then you look at your other equation. So you can say this is 1, equation 1 or whatever. Just name this, right? You can even, I've seen it be called 1. Some people like stars. It doesn't matter. This is just a reference. This is just a reference. Because usually when you have, you can have multiple equations, not just 2. You can have like 4 or 5 equations. And it's kind of hard to keep track of which one is which. That's why usually you label them. The next one is x minus y equals 2, right? This was our other equation. What you do is you're going to replace x in this equation by 6 minus y. So this becomes 6 minus y equals 2. Okay?
Mm-hmm.
Now how do you solve this for y?
Can you change that to 6 minus 2y?
Yep. We're trying to solve for y here. What's next?
Subtract 6.
So negative 2y would be negative 4. Therefore, y would be 2, right? And then
Mm-hmm.
you're going to plug y as 2 up here in equation 1 to solve for x. So therefore, we know y is 2, so x is going to be 6 minus y, which is 6 minus 2, 4. There you go. So the solution is 4 comma 2, x comma y. Make sense?
Mm-hmm.
Now, how do you do this using elimination? Elimination, you're just going to stack them up like this. X plus y equals 6. X minus y is equals to 2. And you either add them or you subtract them. Basically, the idea is to kill off one of the variables. If you subtract them, you're going to kill off x. If you add them, which is always easier, you're going to kill off y. So I'm going to add both of these. X plus x is 2x. Y plus negative y is 0. It just disappears. 6 plus 2 is 8. Therefore, x is 4. And this, you can plug it into any one of the two equations. It doesn't matter. I'm going to plug it into the first one. So x we know is a 4. So 4 plus y equals 6. Y is 2. And there we go. One and done. Right?
Mm-hmm.
Two different ways to solve this problem: substitution or elimination. It's not always going to be easy like this. Like, for example, if this was 2x minus 3y, then you would have to multiply one equation by something, and it gets a little bit more complicated. But this is the most basic system of linear equations that they can ask you, where none of the x and y's have any coefficients attached to them. Alrighty, this one is a dreadful question because you're looking for two numbers, yeah,
Mm-hmm.
that multiply to what? What do they multiply to? 900. No?
Mm-hmm.
What do they add up to?
Negative 60.
Right, now there's so many combinations here to check, right?
Mm-hmm.
There's like hundreds of combinations that you can check. I'm gonna give you a big hint. Usually when you see big numbers like these, it's not that the teachers are evil. They don't want you wasting your time. This one, you wanna check, you're gonna treat it as a square, okay? You see the 60?
Mm-hmm.
This is gonna be in here. By that I mean the two numbers that you're looking for is gonna be, usually it's just gonna be half of what it adds up to. So start by checking that, okay? Just cut it in half. So we know it multiplies to a positive number. So that means both our numbers are either gonna be positive or they're gonna be negative, right?
Mm-hmm.
And they can't both be positive because they're adding up to a negative number. That means both of our numbers are negative, okay?
Mm-hmm.
Both of our numbers are negative. What's half of 60?
30.
30, right? So does negative 30 and negative 30 multiply to 900?
Yes.
Yes, it does. And that's it. So it's gonna be 9x squared. So you usually try and half the middle number. What in the world is this? Usually you just want to half the middle number.
Mm-hmm.
Because otherwise there's a 60. There's so many things that multiply to 60. No, I'm sorry, multiply to 900. You're gonna be sitting there a while. From here it's easy, right? You can pull out a 3x from the first two. You get 3x minus 10. What can you pull out from the next two?
A 5.
A 5. No, you can pull out a 10. Always pull out the maximum things you can pull out. The GCF it's called, right? Greatest common factor.
Mm-hmm.
Always pulling out this. So you pull out a 10, you're left with 3x minus a 10. So then it becomes 3x minus 10 times 3x minus 10. This is what I was talking about when I said it was a square. You see these two, they're the same.
Mm-hmm.
So usually that's going to happen when you half this guy. That's it for that worksheet. Let's look at a different one. I'm gonna try and do some difficult ones, I guess. We can just do it right here. If it says determine if there's enough information to prove that the triangles are congruent. All right, you know what congruent means? What's the difference between similar triangles and congruent triangles? Similar means they have their angles are the same, right? Congruent means not only are their angles the same, their side lengths are also exactly the same. Okay.
Mm-hmm.
Look at question 1. We know xw is equals to yz. We know xy is equals to wz. This is a rectangle, right?
Mm-hmm.
Are their angles the same?
Yes.
Yes, they are, right? This up here, if it's a rectangle, we know it's going to be a 90, right?
Mm-hmm.
And we know this one, I mean, it doesn't have to be 90, 45, but we know that one and this one will be the same. And we know this one and this one will be the same. So yes, these two triangles are not only similar, they're in fact congruent because their side lengths are exactly the same. All right, let's look at this one. We know these two side lengths are the same, right?
Mm-hmm.
I think these two angles are the same. That's what they mean by that. I don't know if that means it's a different thing. We're going to assume these two angles are the same. These two side lengths are the same. It looks like there's going to be a 90-degree down here. These two side lengths are the same. This is going to be equals to this. So yes, they are congruent. Okay.
Mm-hmm.
3. 3 is just a parallelogram. Looks like. Are they the same? Are they congruent?
Yeah.
Yeah, looks like it is because these two angles are the same. That means this angle is going to be equals to this angle. Actually, we don't know if these are parallel. This one is a question mark because if these were parallel, yeah, then we
Mm-hmm.
would be good. But they have not told us that they're parallel, so this one is a question mark. I would say I don't think there's enough information. It's missing that parallel sign on HJ and KL. This one is simple. 4 is like their two angles are the same. Actually, even 4 is a question mark. We know they're similar for sure, right?
Mm-hmm.
Because their two angles are the same, but it's not telling us like this is this, right? We don't know if the
Mm-hmm.
side lengths are the same. So 4 is a question mark as well. What about 5? Is 5 a question mark? Or are they congruent?
They're congruent.
They're congruent, yes. Yes, because this is 90. We know a straight line always adds up to 180. This is 90, right? There's no doubt
Mm-hmm.
about that. What type of a triangle is RSU?
Isosceles.
Yeah, exactly. Isosceles triangle, the base angles are going to be the same, okay?
Mm-hmm.
You see that symbol? The weird looking squiggly symbol between ABD, what we're trying to prove? What does that symbol represent? The symbol, you see this?
Mm-hmm.
This means it's similar, okay? This means it's congruent. Similar, congruent. Cool?
Uh-huh.
All right. Now we need to prove that these two triangles are congruent. B is the midpoint of AE, and B is also the midpoint of CD. So these two angles are going to be the same. Yeah?
Mm-hmm.
Which other angle is going to be the same?
A and C, and then no wait, A and E and C and D.
Yeah, A and C, and sorry, A and E, and then how do I even denote this? This C and this D. So all three angles are the same, right? Two side lengths
Mm-hmm.
are the same. That means the third side length is going to be automatically the same. So yes, these two are going to be congruent. Okay, wait, let me see if there's any interesting questions, because this is a little bit boring. Okay, there we go. We can do these word problems. You see the symbol?
Mm-hmm.
What does that symbol mean?
Similar.
Yeah, similarity. So again, look at this. The way they've drawn this for us, or the way they've labeled it, ABC is here, ABC, and DEF is here, DEF, you see?
Mm-hmm.
Scale factor is 7 to 2. That means 7, 2. What does that mean actually? Which triangle do you think is bigger? Scale factor of 7 to 2.
The first one.
Yeah, the first one is 1 unit is worth 7 here. The other one is worth 2. So if this is 14, the question is, how do you find this? I'll give you a hint. It's either going to be 14 times 7 over 2, or it's going to be 14 times 2 over 7. It can only be one of these two. Usually it's we've been doing this, right? It's always going to be a side length times the scale factor.
Mm-hmm.
If you do this, you get 49, because 2 goes into 14 7 times. If you do this, you get a 4. So is DE 4 or is DE 49? Remember, D is going to be smaller than AB.
It's 4.
It's 4, has to be 4. Cool.
Mm-hmm.
Let's look at 17. Scale factor 1 to 2. Oh, this is a trick question. Which one is bigger anyways? Scale factor of 1 to 2.
The second one.
Yeah, the second one. D, E, F. It says if A is 30 degrees, right? We know the scale
Mm-hmm.
factor is 1 to 2. What is angle D? So yeah, what's angle D? That's the question. When a scale factor is 1 to 2. For our purposes, it's 2. It's 60, no?
Mm-hmm.
No, it's not. I'm trying to trick you. They're trying to trick us. It's not going to be 60. The angles don't multiply by 2. The angles are going to be exactly the same. These 30. It's the side lengths that are going to go up and down. The angles in a similar triangle are going to stay exactly the same. So therefore, D is going to be 30. Cool?
Uh-huh.
It's a trick question there. 18. We have ABC, which is a little bit bigger than DEF. EF is 20. we want to find BC. Is it going to be 20 times 5 over 4? Or is it going to be 20 times 4 over 5? Look at it this way. We know it's going to go up, right?
Mm-hmm.
It's going to go up. When I say go up, I mean you need to be multiplying by more than 1. This is less than 1. You see, this 4 over 5 is not even 1. That's 0.8-ish, but it's 4 out of 5. That's less than 1. Whereas 5 out of 4 is more than 1. We need we need this 20 to go up. We need to multiply it by a number that's bigger than 1. It must be this one, 5 over 4. Can't be 4 over 5. 4 goes into 25 times, BC is going to be 25 units. And you're done. Cool?
Mm-hmm.
What about this one? This one could be another trick question. What is this going to be?
Yeah.
EF looks like it is, but does that make sense? 80 degrees is going to be, well, this is 90-ish. Or we
Mm-hmm.
can just draw it like here. We can just kind of make our own sketch. 80 is going to be like this. Maybe even slightly. 70 is going to be like this. Looks like it is EF. 80, 70. Yeah, it cannot be these two because they're not going to meet. We're going to go with EF. But I feel like that was a trick question. Could it be 20? There's no answer here, but I think it's going to be EF. Let's look at this. It's going to be, see, now the scale factors are not whole numbers. Already. You see this symbol? What does that mean?
Similar.
They're similar, right? So we don't have to worry about proving that they're similar. It says find the perimeter of RST. We talked about this before. When it comes to area big is gonna be area small times k squared. For side length, it's gonna be the length of the big is gonna be length of the small times k. Okay.
Mm-hmm.
Perimeter is basically the same as the side length. It's gonna be perimeter of the big is gonna be perimeter of the small times the scale factor. What's the perimeter here?
54.
36, 54. Great. Now think about this. We know we're trying to find the perimeter of the smaller triangle. Yeah. There's only two things you can do. Do you multiply it by 4 over 3 or do you multiply it by 3 over 4?
By 3 over 4.
Yeah, exactly. We need it to go down, right? We need it to multiply by a number less than 1. We're going to be super lazy here. We know the perimeter of this is going to be less than 54. If you look at the options, bigger than 54, bigger than 54, bigger than 54. It must be A, right?
Mm-hmm.
All right. A 16-foot ladder. So there's this ladder. it leans against a wall. Let's say this is the wall, and it's 8 feet from the base of the wall. Like that. This is 16, this is 8. How high up the wall does the ladder touch?
You use Pythagoras theorem?
Yeah, you do. So it's gonna be, you can call this x or whatever. X is gonna be 16 squared times 8 squared, right? Cannot be 24 because the longest side of a triangle is the hypotenuse. Cannot be more than 16. 16 squared minus 8 squared. Square root of that. I got 13.85. That means it's gonna be 14. It says to the nearest foot, so we round it up. And the answer is gonna be 14. Make sense? Now, how difficult does this get? All right, it's asking us to find the hypotenuse. They've only given us one side, so we can't really use Pythagoras theorem. What do we do? Any ideas on how to solve this? It has nothing to do with similar triangles. You need to use trig.
SOHCAHTOA?
Yep. Which side length have they given you? Actually, you can, if you really want, you can use Pythagoras actually, because you see 45 here? What does that mean this side is gonna be? What's the angle up there?
45?
45. So what kind of a triangle is this? They have the same angles down here and up there, yeah? So this is a isosceles. So this is also gonna be 12. The hypotenuse, there's no, it's gonna be less than 12. So A and B is out, even C is out. It's gonna be D and E. I'm thinking it's gonna be D because E is too much, but we can check. It's gonna be 12 squared plus 12 squared. So it's 16.97, which is D. So that's the Pythagoras way of doing it. But you have to recognize that it's an isosceles triangle. If you use the SOHCAHTOA approach, it's gonna be like this. You're given the adjacent side relative to the angle, right? You're looking for your hypotenuse and you know your angle. Which one uses A and H?
Cos?
Cos. So you have cos of 45 is equals to the adjacent divided by the hypotenuse. How do you solve this for x?
Do you just do 12 divided by cos of 45?
Yeah. You can, yeah, you usually you just swap positions with this. X is gonna be 12 over cos 45, which is the same thing as multiplying both sides by x first and then dividing both sides by cos 45. So you get 12 divided by cosine 45. The answer is again 16.97, which is 17. Make sense? Not too hard, right?
No.
Let's see if we get some nice word problems. But again, that's gonna be the trickiest question. It's always the trickiest questions are like the word problems. There's no word problems here. There we go. We can just do it right here. Look at that triangle that forms. It says, how far is the bottom of the treehouse off the ground? You understand what they're asking you? What are they asking? Which side are we trying to find? What are we trying to find?
Like the middle line?
Yeah, the height of the triangle, basically. How do we do this?
First, you could find the hypotenuse.
That is the hypotenuse is 5. No?
Like of the bigger triangle?
So the bigger triangle is not going to have a hypotenuse because it's not a right angled triangle.
Mm-hmm.
Basically, what's going to happen is this is going to be 45. This is going to be 45. And then you can just use opposite. You can use sine. Sine 45 is going to be x over 5. Therefore, x is going to be 5 times sine 45, whatever that is on a calculator. Cool?
Uh-huh.
That's it for that. So it's a right angle triangles can be isosceles. Okay, this one looks interesting. If the length of the base of the building is as tall as the total height, so this is 4.8 as well. So that means this is 4.8. Yeah.
Mm-hmm.
So it's asking us to find this side length. What do we do? We basically need to find this height, right? What if we turn this? Is it possible to find that height? We could find this side here. Don't know how much it's going to help us. Wait a second, maybe I'm misreading the question. If the base of the building is as tall as the total height, how tall is the wall? What's 4.8 here? Must be this, right? 4.8 squared minus 2.5 squared. So this is 4.1. So we have all 3 sides of the triangle. Yeah.
Mm-hmm.
We somehow need to find this side here. That's gonna be a 90 degree. Okay, I think I get it. So this here, this is gonna be 4.8 minus 4.1. It's gonna be 0.7, right? Then we can use
Mm-hmm.
Pythagoras theorem to find that. It's gonna be 2.5 squared plus 0.7 squared. And to find the final answer, you just do, that's gonna give you this height. You just do 4.8 minus that, and you're done. Cool?
Mm-hmm.
All right, let's pick it up next time.
All right. Thank you.
See ya.